So these word problems for your exponential model are going to read this way. It's going to say the rate of change of a quantity, but it might not say of a quantity. It might say of elephants. I don't know, whatever it is, whatever they make the problem about, is proportional to the size of the quantity. They do this a lot for population because population growths are often exponential. But what that means is rate of change means a derivative. So it's going to be dy dt. T stands for time. Y is whatever the amount is. I wrote Y on here, but again, if you were doing population, it would be P, and then it would be dP dt. Do you remember when we did rate of change of volumes and it was dV dt and everything was dt? Okay, good. Head's nodding. I love it. Is proportional to. That means you take that thing, whatever it is, in this case, we're calling it Y, leave a little gap there, and you scale it by something. The example I always use is, you know how there's the actual Eiffel Tower in real life, and then there are Eiffel Tower keychains that you can buy, and it's a scale model of it. You're just multiplying by some scale, and we always use K for that. I don't know why someone chose that it was going to be K. That's just what they've decided it is. Go with it. This is going to look like we've jammed every letter of the alphabet into this thing, so just you trust the process for a couple of minutes, all right? So the rate of growth of bacteria is proportional to the number present. It's going to sound like that. Write an equation to represent this situation. I'm going to have you actually do this once, and then after that, we're going to just kind of memorize the formula. So you're going to have dy, or actually, we're not going to use y. What is it, bacteria? We're going to say b, db dt equals K times B. Separate, integrate, plus C, initial condition, blah, blah, blah. All right. B is going to go to the left. T is going to go to the right. Would you add, subtract, multiply, or divide this B to the other side? But so it's going to be 1 over B dB equals K dt. And then we're going to do our antiderivative. So what is your antiderivative for 1 over B? Yeah, ln B. Now this is a little tricky. K is a number. It's a scale. You've scaled it by something. Think of the Eiffel Tower, all right? Pretend it's a 3. What would be your antiderivative with dt of, yeah, it'd be kt, good, plus C. There's like no numbers in that. It's literally all letters. Okay, keep on going. You want to get rid of the ln. So here comes another letter of the alphabet. How do you cancel E, right? Kind of like teaching this because it is sort of funny. All right, when you cancel that out, E and ln cancel. It's just going to be B. I know there's an absolute value, but I'm not going to put plus minus. You can't have negative bacteria. These are going to be story problems. Usually you can't have a negative amount of something, so you're not usually going to have a negative with these. Remember, E is a number and C is a number, so we put that out front. So it's CE to the KT. This is what your equation is going to look like. I taught a lot of you in pre-calc, so we'll see how this goes. Do you remember PERT?
Yeah.
The PERT formula were interest rates. That's what that is. PE to the power RT. Okay, that is what this is PERT. So you have actually done this before. It's not really calculus, it's pre-calculus. Okay. I'm going to use PERT because you've heard that before. The calculus way that you see it is you'll see Y equals, and instead of R, they use K. Again, I don't know why they use K. Oh, oops. Oh, I wrote it wrong. Oh my gosh. I'm so mad. I feel like ditching this recording and starting over. Maybe I'll record this with my class tomorrow. I put it in the wrong place. I'm sorry. I was so excited to say PERT to you. I wrote it in the wrong place. It's Y equals PE to the RT. I'm so sorry. The PERT has to all be on the same side. Oh, I'm so mad at myself now. I know, but I need to be perfect. But the way you're going to see it in calculus is it's going to be kekekt. I don't know why, but what you see, because it's plus C for a constant, and I don't know why they picked K to be the rate. So it's going to be like kekt or whatever, but it's PERT, okay? So go with it. So now we're going to put some actual numbers in here, and you get a calculator for this. It says there are 300 bacteria initially. That's going to be this C value. So we're going to have bacteria equals 300 e to the power kt. So that's your initial condition. That's what you start with. And if you remembered last year to pre-calc, P stood for principal. It was money, and like that's how much money you put into the bank, and then you had an interest rate and you like earned more money. Do you remember this at all? There are videos. I have video recordings of it. All right. There are 700 bacteria 10 minutes later. So you're going to put in 700 for your amount of bacteria. And then 10 is going to go in for what? T is time. And then we're going to solve that. Again, it's not calculus. This is like that. We're really just doing pre-calc here. What would you do to both sides to begin solving? Yeah, divide by 300. So 700 divided by 300 is 7/3. A number was correct. Specifically 7/3. All right, then what? You need to get rid of E. ln, good. ln 7/3 equals k times 10. Bless you. And then your last step, divide by 10. You don't want to reach for the calculator until the very end. But I'm going to share my screen. And I just need for you to watch and we'll put in. All right, so it is ln 7/3 whole thing divided by 10. It's a decimal, but it came out to a positive number. That's because the amount of bacteria is increasing because derivative is positive. Remember that first derivative test? Okay, so that is your K value. Now on the paper, I'm only going to write 3 decimal points, 0.084. But if I reuse that number, I'm going to copy paste this. You want to use all the decimals. I'm going to leave it there for right now. All right. Now, it didn't say what is K. It said write an equation. So to write my full equation, it's bacteria equals, how many did we start with? We got 300 e to the power that times t. That's your rate. And again, I know it's a decimal, but it's a positive decimal, bless you, because you're getting more and more bacteria. Ew, gross. So part C says use that equation to predict the number of bacteria after 20 minutes. Well, what are you going to do with 20? Yeah, plug it in for time. I don't even have any work for that. I'm just going to type it in, but I need for you guys to watch because I am going to copy paste that number. If you don't copy paste, it won't be accurate enough. It's 300 e to the power. This number, look, I'm going to highlight it, copy, I did Control C, paste, Control V, 10 times 20 for the 20 minutes, 1,633 and a third bacteria. Yes, or that was a good question. Can you guys all listen to that? If you didn't want to copy paste that, you can type ln 7/3 divided by 10 and it will come out the same. I don't mind decimal pointing a bacteria. I don't feel bad for them. We'll chop a bacteria into a third. All right. Heads up, this one is not going to be fun. You aren't going to like this one very much. Why do you think I put it on here? I found one on AP Classroom and copy pasted. I was like, oh, if they did that, we better do that in class. All right. The rate of change, because I think this one you don't use a calculator for. Yeah, we're going to just leave this one alone. I'm going to make sure I don't mess this up. All right. The rate of change of a certain population, again, they do population a lot for this because populations grow exponentially, is proportional to the population. When you see that, you need to know it's PERT or KEKEKT or whatever you want to say. Okay. So when you see those words, that is, what that means. All right, at time 0 years, the population is 500 people. So it's going to be, or do you want to use Y equals, or do you want me to put P for population? Doesn't really matter to me. Just Y, okay. So Y equals 500 e to the power KT. It says we're starting with 500 people. After 4 years, the population is 750 people. So we're going to put 750 in for the population. Again, if you wanted to put P equals, like I did B equals for bacteria and the other one, you could. Equals 500 e to the power K times 4. And then we're going to solve that. So what would you do to both sides? Yeah, you divide by 500. That would be what, the same as 75 over 50. So 3 over 2 equals e to the power k times 4. All right, then what? These all solve the same way. Yeah, ln to cancel out e, and then divide by 4. This one's going to be a no calculator. So we're going to actually just leave it like that, which seems like you preferred that, so that'll be good.
Think point does not matter, but when we're doing the LN, is it okay? Like, does it matter if we're using quantities or for absolute value?
So it technically doesn't, but you only need an absolute value if there's a variable in there. If it's just a number, you can put parentheses, but no one's going to mark it wrong because you put an absolute value. That's being like extra, you're being a purist. You're like a mathematical purist. Like, I want it to be perfect. All right, so then to answer the next part of the question, so we found our k value. At what time was the population 600 people? So we're going to go back to the beginning. Where is the 600 going to get plugged in for if it's the amount of people? Y. Good. So it's going to be 600 equals 500 e to the power. Now, what is k? Yeah, it's going to be messy. It's not hard. You just have to rewrite it. ln 3/2 over 4 times t. And we're going to solve for t. It's just going to look awful. It's not going to be hard. It's just going to look awful. What would you do to both sides? Hint, it's a lot the same as what we just did. Divide. So it would be 6/5 equals that. And then ln, let me just pause a second. Some people can't write that fast. So, but yeah, your next step is ln. Well, I don't want to leave anybody behind. Now this is divided by 4, so to cancel that out, you'd multiply by 4. I think the easiest way to do that without having to write the whole thing over again is slap a 4 out front. And then your last step is to divide by, we actually don't need to, we just need to get t by itself. So we're going to take this and just divide it to the other side. So it'll look like that, which is great. Don't discriminate. It's a perfect answer. If you had an ln of t, then you would have to do e to cancel out the. That was a really good question. Did you guys understand the subtle difference there? Like if you had ln of t, but the t was just getting multiplied by this, so we just divided it over. Cool. You guys are hanging in there. All right, this is going to be like a sciencey thing. You'll have to let me know if anyone did this in chemistry. Have you all taken chemistry?
Oh, yes, I.
Okay. So doubling time is time it takes to double what you have or to have twice as much. So whatever you started with needs to be increasing. So like the bacteria. So, but the important thing is that it's time. It's the time it takes for the amount that you had to now be twice as much. And same for half-life. Again, you have to remember it's time. Time it takes to have half as much as you started with. So in that case, your amount would have to be decreasing. Typically, this shows up in chemistry because you'll get a problem that's like an element is decaying over time. Do you know what I'm saying? Like, and then they'll give you a half-life. Or also in medicine, I don't know if anybody's going to go into the medical field. Half-life for a medicine, like it takes a certain amount of time for your body to metabolize Tylenol and all that. Do you know what I'm talking about? This is where the math is actually real, you know, so like it's kind of cool. I know you're like, we're bored, but it's cool. All right. Right? Well, I mean, well, do you want your doctor to not know how long it takes you to metabolize a certain drug and then like overdose you? No, I mean, it's important, right? That's why they do studies and things like that. All right. An element has a half-life of 1,500 years. That's usually a long time. It takes a long time for elements to break down. An initial amount of 200 grams. So it's going to look like this. You initially have 200 grams. It's your PERT or your KECT, however you want to think of that. Now, again, what's important to remember is this is time. So that 1500 is going to get put in for T. And I left the Y blank because we do have to put a number there, but it's not given in the problem. However, I believe in my heart you can figure it out. If we started with 200 grams and it's a half-life, how many grams do we end up with? 100. Half as much as you started with. It takes things a long time to decay. You know what I'm saying? And then you're going to solve it. So when you divide that over, oh my gosh, we ended up with a half. Ain't that crazy? What? Some people will even skip that step. All right, equals e to the power k times 1500. And then ln, I'm speeding this up because this is not any different than what we did before. And then you would divide by 1500. I'm going to leave that alone because you guys seem to handle that. You could type it in and get a decimal and then copy paste the decimal, but you guys seemed all right with that. So I'm going to just leave it alone. We want to find the amount after 10,000 years. There's probably not a whole lot left after 10,000 years. Okay. So you're going to start back over at the beginning and we're going to have y equals 200 e to the power. Now what's k? That, right? And again, you could type that into the calculator and get a decimal if you prefer that. And then times T, which is 10,000. Did I put enough zeros? Yeah, there we go. All right, so let's see how many grams we have left. We started with 200 grams. This is after 10,000 years as I'm typing this. And I guess we did actually kind of start off with a lot. 200 is kind of a lot. E to the power, oh goodness. ln of 1/2 over 1500. I didn't highlight the whole thing. Hold on. Then times. Yeah, you know what? That's right. ln of 1/2. Want just that part divided by. There we go. 1500, and then I want to do times 1,000. 1.968 grams. Well, you started with 200 though, so what did you say? What was your guess? Oh, you got that. Oh, good job. All right. Money. You put $500 in an account. All right, so that's what you start with. It's going to look like this. It takes 6 years to double. If you started with $500 and it doubled, you now have 1,000, and then the time is 6 years. When you divide over the 500, guess what you get? 2, because we doubled it. You're going to be okay. And then ln. Oh, copy error. Sorry. Thank you. Was the other one 10? Where did I get a 10 from? Oh, because I wrote 1,000? I don't know why I wrote 10. Was one on the other side of the paper 10? Oh, there was one on the other side of the paper that had a 10 in it. All right. And then you're going to divide by 6. So ln 2 over 6, whatever that is. All right, how much money is in the account after 8 years? You start back over at the beginning. So it's 500 e to the power, that thing, k. Again, or, and I do this a lot in my classes. I'll wait and see how you guys feel about it. And you guys seem to prefer that. So that's what I'm writing. But again, you could type that in and just copy paste the decimal. All right, times 8. I'm expecting this to be bigger than 500. If we start with 500 and something larger, we should have, more money. Oh my gosh, did it all of a sudden get really, really cold? I felt AC come on. Don't stop listening to me while I'm typing this. You're gonna have to be able to type things. Okay, good. We got a number bigger than 500. $1,259 and 0.921. Ew.
Should we only do two?
I just always do 3 to be safe.
Thanks.
All right, last one. Sales of TVs in thousands follows this model. 10,000 TVs get sold in 1 year, and the saturation point for the market is 50,000 TVs. What that means is, listen, TVs are not something that you continually buy weekly. For example, toothpaste. You would keep buying that over and over and over again. Do you see what I'm saying? Televisions are not like toothpaste. Once you buy a television, usually you're set for like a while. You're not going to buy one every month. Okay. So what that means is if you're a television salesperson, you're going to eventually saturate the market. You've sold enough TVs that no one else is going to buy one, and you're kind of out of luck. Do you get what I'm saying? That should feel like a limit. It's going to be limit as time goes onward. Limit time to infinity of this model right here, C e to the power. Now that one's K over T. They changed it a little bit. Is going to equal, now what's our saturation point? Yeah, now it's actually only 50. Why am I going to just put 50? Because it's in thousands, okay? So let's think about what that is going to turn out to as time gets bigger and bigger and bigger. If time is this denominator, and you need to think of like the largest number possible, bigger than that. How about 12 trillion? I don't care what K is. If you have something over 12 trillion, like 1 over 12 trillion, that's super, super close to what? Now, good, perfect. E to the 0. Good, you used brain and then spoke. Usually people shout out 0 without thinking. Use brain, then speak is what I always say. E to the 0 power is 1. And then 1 times C is C. So C is 50. What that means is you're leveling off at 50,000 televisions. Okay. So let's go ahead and rewrite our equation. It's going to be S equals 50 e to the power K over T. And I still need to find that K value. That's like the thing that we're missing. So what else did they tell us in the equation that I could start like plugging some stuff in? Well, I can't plug in the 3. That's my final answer thing. In 1 year, so when T is 1, 10,000, I'm going to just put 10 because it's in thousands. And I just wrote E to the K. What happens to T? Yeah, it goes away because it was 1. And now we're going to solve. So you would divide over the 50. And then what? Yep, ln. So ln 1/5 equals K. Now we're going to answer the question, how many TVs are sold in 3 years? So our C value we said was 50. So we're going to have S equals 50 e to the power K, which we just said was ln of a 5th over T, which is 3. And I'm going to go type that in. Don't like stare off into space while I'm typing this. Watch me type it because, you know, using the calculator is a skill that you're going to need. All right, 50. And also, if I type it wrong, it's wrong. So I need for you guys to, you know, tell me if I mess it up. I need you to be like, hey, you messed that up. All right. I don't want that. I want this part. There we go. Divided by 3. All right. Not 29 televisions.
29,000.
Good. It is 29,240 televisions. Well, I wouldn't, you know, I decimal pointed the bacteria. I would not decimal point a television. You kind of need to round to a whole number of televisions. Yeah, I can't sell you like can't like break this one into pieces and then sell you part of it, you know.